All right. Oh, you don't want to look at this. You want to look at this. Okay. You guys have watched this video with the annoying song that showed you that a squared plus b squared equals c squared. You believe it? It's called the Pythagorean theorem. You might have done this last year. You might not have, but we're going to do it a little bit, take it a little further. We're going to make sure that we incorporate what we learned about radicals as well. So these are all the answers. This is my teacher's edition. Now I'm just going to show you how to get a few of the answers. You should have a calculator and your 9.1e lesson. Here we go. So the only thing you have to know is which side is which, and C is always called the hypotenuse. This is the one that's the important one. Hypotenuse. And it's the one that's always opposite the right angle. So here's the right angle. Think of the right angle as pointing to the hypotenuse. This is the one that's important because you could actually interchange A and B because you can add in any order you want. So clearly we're looking for C. So you do 9 squared plus 12 squared equals C squared. I don't need a calculator for either one of these, neither do you. 81 plus 144 equals C squared. Now if you would like to use a calculator to add those together, you could. But C squared equals 225. Maybe I need a calculator. And I don't want to know what C squared is. I want to know what C is. And clearly to do that, you need to take the square root of that number and that to get it to be a C. Square root of 225, as you know, is 15. And we got the right answer. Congratulations. Okay, here's something I want to make sure you understand. If their answers have a radical in them, you need to simplify the radical. Clearly this doesn't have a radical because 225 is a perfect square. So this one, you see there's going to be a radical in their answer, and let's make sure we understand how to do this. So again, doesn't matter if you want to call this A or B as long as we know we're looking for that one. So 2 squared plus 6 squared equals C squared. 4 plus 36 equals C squared. 4 plus 36 is 40 equals C squared. Slowing down, pausing. I don't want to know what C squared is. I want to know what C is. So in order to do that, how do you unsquare something? And you should be saying to yourself or out loud, you square root it. So whatever I do to one side of an equation, I do to the other. So C is equal to the square root of 40, also known as radical 40. But if you remember from Module 7, radical 40 can be simplified, and what are the two factors of 40 that will help us? And hopefully you remember that it is, one of them is a perfect square. So the square root of 4 is 2, what leaves us with 2 radical 10. Okay, and that is the actual exact answer. That would just be an approximation if I took the square root of 40. Okay, we'll skip number 4 for now, just because it's just decimals, it's nothing new, no big deal. Okay, and now in this case, we're going to use a Pythagorean theorem and again do it in simplest radical form. Well, this one's easy. We'll skip that one. This one is the only one I want to do from this section that's a little bit different. Well, actually 6 and 8, so we'll skip 7. So clearly in this case we're looking for B, and that means that one of these is C. Now one thing you need to know is that C always has to be the longest side of the triangle. And it's also the one, of course, that's opposite the right angle. Pardon me. Okay, so that gives us that must be A. So 24 squared plus what we're looking for, B squared, equals 25 squared. Lights shut off, hang on. Okay, 24 squared is 576. That's right here, 576 plus B squared equals 25 squared. You should know, but it's 625. 625. Now the only thing different about this from the previous ones is that C was the unknown value and it was already isolated on one side of the equal sign. Whereas this one, we're trying to find B, but it's not by itself. So to get B squared by itself, we would need to subtract 576 from both sides. And I'm just going to move over here. And again, 625 minus 576 Just use a calculator if you need it, and look what it comes out to be. Do you recognize why that's a good number? And you should say yes, because it's a perfect square. B squared is equal to 49. Therefore, the square root of that must be what B is, which is 7. Okay, skip number 7 like I said, and then we'll go on to number 8. Okay, number 8. Let it get focused for a second. There we go. So again, A, B, C, or A, B, C. I don't care as long as I know that is C. So this one's going to be a little bit unusual because it has a radical in the original problem. So again, let's just call this the first number. X squared plus 10 squared equals 10 radical 2 all squared. X squared plus, don't say 20, 100 equals. Now, what does this mean? This expression means that times that squared. This and that both multiplying themselves. Okay, so I'll write it out just down here. It's 10 radical 2 times another 10 radical 2. Now guys, these are just multiplication of different terms here. This is just 10 times 10, which is still 100. But radical 2 times radical 2 is radical 4, isn't it? That times that is that. And radical 2 times radical 2 gives us a perfect square. So radical 2 times radical 2 is radical 4, which is really 2. So this is that, isn't it? Everybody got it? So when you square 10, you get 100. When you square a radical, you end up with a perfect square, and then you just really have the number that was under the radical to begin with. So this is really 200 equals x squared plus 100. Look over this, back up the video if you need to understand why that is, okay? Subtract 100 from both sides. You get x squared equals 100, and then the square root of x squared is x, and the square root of 100 is 10. We got it. Okay, next page. All right, again, 9 and 10, bye-bye. So let's go ahead and do this problem, number 11. So what do you notice about these two sides, besides that they're x? You should say that they are the same. So if this is x, and this is x, and I combine these, it's really like the same thing. Let me show you what I'm saying. This is x squared plus another x squared equals 20 squared. And by the way, why is this c? Because it's the opposite of the right angle. Okay? Now, if I have x squared and another x squared, aren't those like terms? Can't I combine those like I was saying just a second ago? Well, think of algebra tiles. If I have x squared and x squared, don't I have 2x squared equals, do you know what 20 squared is? If not, put it in your calculator. It's 400. Okay? Now, this looks a little different than the last ones, but don't you know how to get rid of this 2 that's multiplying? And of course you do. You just divide, and then come down here. 2x squared divided by 2 is just x squared equals, and 400 divided by 2 is 200, right? Now remember, we don't want to know what x squared is, we want to know what x is, and you see the answer here, but let's see how we get from here to here. So you square root both sides. So x equals, and you might be asking yourself, well, why am I not putting plus and minus here? Well, the reason you're not actually doing that is because we're talking about physical sides of a triangle, which we cannot include negative values for. It doesn't make sense. So x squared is, x is the square root of x squared. What's the square root of 200? And if you remember, you're looking for perfect square factors. Think of this as 100 times 2. Out would come what? Square root of 100 is, you see it there, 10. What's left under the radical? 2. And that's how they got that answer, 10 radical 2. Okay, let's do number 12. Same way. They're telling us this is A. This must be what? B, I hope you said. And that must be C. So A squared plus 4 squared equals the square root of 41 squared. All right. A squared plus 16 equals, now again, if you multiply the square root of 41 times the square root of 41, you get a big old number. I'll just do it to placate you, and that means satisfy your wants here. 41 times 41 is a big number. But it's not that number, 1681. It's the square root of that number. And guess what the square root of 1681 is? Take a guess what the square root of 1681 is. Oh, if you guessed 41, you understand what we're actually doing here. When you square a number under a radical, you get a perfect square that has that as its answer. So the answer is just 41. Okay, subtract 16. A squared equals 41 minus 16. Isn't that 25, I think? And guess what? You square root both sides. What does A equal? And the answer is 5. Okay? Pretty easy, right? Okay, we're down to the last few questions. I'm only going to do a handful of these, not all of them. I'm going to definitely do one of these because you need to know what a diagonal of a rectangle is, and clearly that is the diagonal of a rectangle. And in this one, it's a diagonal of a square. It's from one corner to the other. That's not obviously one of the perimeter of the rectangle. So if they want to know the length of the diagonal, and it has a width of 1 and a length of 4, really you think of this as a right triangle. So here's A, here's B, here's C, or here's A, here's B, and this is C. This is the unknown value. So you would just do the same exact thing. So 1 squared plus 4 squared equals x squared. That's 1, that's 16, that's x squared. Add 1 and 16 together, you get 17 equals x squared. You don't want to know what x squared is, you want to know what x is, so you square root both sides, and x equals the square root of 17. Radical 17 cannot be simplified, so you can leave it like that. Go ahead and try this one and see what you get, and then go ahead and press pause. I'll wait for a moment. Your substitute teacher should press pause now. Did you get 2 inches? I hope so. Last problems. All you need to do is determine whether they satisfy the Pythagorean theorem. And what that word satisfy means is, does it make the Pythagorean theorem true with a question mark? Okay. So the only thing you need to know is that the legs are the shorter side, the hypotenuse is the longest side, and then enter them into the equation correctly. This is just a plug in and go. And again, you see all the answers here because this is the teacher's edition, but you need to prove it. So, longest side must be C. These are A and B. I don't care which order, but let's just say that. So does 11 squared plus 60 squared equal 61 squared? And your calculator can tell you that answer quickly. So 11 squared plus 60 squared equals, and does that equal 61 squared? And clearly the answer is yes, so that's why that works. I'll do another one that has a radical in it. Let's just do number 18 and then we're done. So what you need to know though is which one's A, B, and C. Now what's longer, 3 or the square root of 10? And if you don't know, you can cheat and use a calculator, or you can use your brain. The square root of 10, isn't that slightly bigger than the square root of 9? And guess what the square root of 9 is? 3. So A, B, C. So does 1 squared plus 3 squared equal the square root of 10 squared? Let's find out. 1 plus 9, which is 10, does that equal, well, what is the square root of 10 times the square root of 10? Let me actually write it out. What's radical 10, radical 10? Doesn't that equal radical, I can even write it larger, doesn't it equal radical 100? Which is equal to 10. So that's why the answer to this one is also yes. Now, if it doesn't work, like for example in this one, the answer would be no. Does 2 squared plus 4 squared equal 6 squared? Does 4 plus 16 equal 36? No, that's why the answer is no. I finished just in time. That's all we have for today. Enjoy. I will see you next week. Adios.